Today, it's going to be a little bit special kasi tuturo ko kayo ng probability on steroids. Dahil gagawa tayo ng probability, o magkukulit tayo ng probability from simple probability all the way to two-way table probability. And if you want to know more about probability, just stick around at manood kayo ng video ko. This one is a two-way table. So they took a survey in a certain university and they asked around if the students have ear piercing or no ear piercing or no ear piercing, either male or female, right?
Yes.
Right?
Yes.
Because male can wear earrings, right?
Yes. Yes.
All right.
Why don't you have any?
I used to. All right. So let's answer each probability. So for the first one, pierced ears, which means pierced ears. Yes, right?
103.
Total of 103. Out of the total number of students, which is 178. So that is the probability, which is about 58%, right? What about the second one? Male and has pierced ears. Is it a union or intersection? Intersection. Which means they need to have both qualities, right? Male has ear piercing. 19 out of always the total, because there's no condition yet. All of them are students, right? So it's 19 out of 178, which is about what? 11%. Smaller, obviously, because they need to have both qualities. Male or has ear piercing. It will be male
90.
or has ear piercing. Right? So what are we going to add then? 71 plus
84.
19
Wait.
plus
84.
84.
Or 90 plus 84.
All over 178. Can I use 90 plus 103 over 178?
No.
Why not?
You've been counting.
Because you're going to count male and ear piercing twice. So be careful when you're working with an OR operation. Make sure that you know that you're just adding those elements. Got it?
Yeah.
Okay.
And this is different from what it says given.
Yes, that's what we're going to be working on afterwards. So this one, non-conditional because there's no conditions. It's either this, from a sample space of all students, right? Now, how is it going to change? This is how it's going to change. Let's have the same table, but this time we have this symbol right here, which is what we call as the conditional statement. So the conditional statement in statistics, this particular sign is where we attached or where we use the word given or the condition is. So this one, if we translate this in English form, it can be written as probability of and this is how you translate math notations into a language that you can understand. Got it? Because in statistics and in probability, to be able to answer complex questions like this, you need to know how to use the language and the symbols really well. So, when we translated this in English form, the condition is that that particular student should be a student with ear piercing, right? Right?
Mm-hmm.
Ear piercing.
Yes.
Yes. So that means our sample space are only students with ear piercing.
103.
103 is our sample space. So our denominator is going to be 103. What will be our numerator?
19.
It will be the intersection of the two conditions that was mentioned in this probability question, which is male with ear piercing. Male and ear piercing. So that is how you compute conditional probability when you have a two-way table. Got it? So for number one, your answer is simply 19 out of 103. Got it?
Mm-hmm.
So can you please give me the value for those other two fractions for conditional probability? What's the probability that a student selected is a female given that she has ear piercing?
84.
84 out of 103?
Yes.
What about female given, not pierced ears?
4 out of 75.
Okay, so you know that you are really understanding conditional probability and regular probability in two-way table if you are not guessing. If you are accurately getting the fractions correctly, that means you know your rules. Because that's what most students do sometimes. They guess and they got it right, but not really understanding what they're supposed to be doing. Again, the condition or the second adjective would be your sample space in this notation. But it could also be in a different form, which I'm going to show in a little while. Wow!
I think the 84 out of 103 is 81%.
Not 18%?
No, because that would be the same.
Crap. I'm going to edit it. Typo. I'm just going to say typo. Alright, now, as I was saying, sometimes notation is easier to work with in statistics, but sometimes they use word problems. Here's one. Alright, here's your question. Given that a student is a male, what is the probability that he has ear piercing in this particular group of students? So, what is your answer? Tell me.
19 out of 90.
19 out of
90.
90. So, let's see if it's 19 out of 90, because given that the student is a male, if we're going to write this in notation form, your second statement will be
Male.
male. So that is your condition. What is the probability that he has ear piercing? And this is how you translate it in statistical notation. Got it? So now you know it's male, sample space, ear pierce, intersection, 19 out of 90. Alright? And that's how we work on problem involving two-way table. And that's all there is. One-way table, two-way table. Now, we're working on the last type of probability that you need to answer. Probability in tree diagram. And this is not a regular tree diagram that is similar to flipping a coin. This is a tree diagram that is basically giving or in the basis of the word problem that you are working on. Tennis. Do you know how to play tennis?
Negative.
Alright, so just like working with classical probability, if you have not seen a die, how are you going to answer a question like, what's the probability of getting an even number when you roll a die? Got it? So it's extremely important you know the sample space and the situation and the experiment you're working on. And in this case, the experiment is playing tennis. You're allowed to do 2 serves. Do you know that? Alright. If on the first serve, boom, it's in, then it's a game. Boom, 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 go, go, go. Then you earn a point, whoever gets a point. Alright. There's a second chance in playing tennis. In the first serve, you miss the ball, it's okay. Because you have a second chance. But that's the only chance you have. And then you hit it, and then the game continues, and then you can still earn a point. Got it? So that is how you play or earn points or point in a game of tennis. Alright, let's say you know Roger Federer. So tennis great Roger Federer made 63% of his first serves in 2011 season. When Federer made his first serve, he won 78% of the time. First serve, boom, 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 he wins. Got it? When Federer missed his first serve and had to serve again, he won 57% of the time. Got it? Suppose we randomly choose a point on which Federer served. What is, boom, it's right here. What is the probability that Roger missed his first serve given that he wins a point? Then it becomes problematic, right? Can you visualize this? What is the probability that Roger misses first serve given that he wins a point? So are you visualizing what you're supposed to be computing? Because that's the first step. You need to know or understand and visualize what you're supposed to be computing. What is the probability Roger missed his first serve? So he served on the second, he played on the second serve, and then he wins a point.
Yes.
That's the probability that we're computing. Got it?
Yes.
Okay. This is where the tree diagram is going to put into play. Since there are two servers, it's like making babies. Firstborn and secondborn. Got it? But not like the same. Which means we're just going to be doing two branches here. The first branch, what do you think is the first branch in our tree diagram? Makes it on the first serve, right? What is the second option? Missing it. Miss the first serve. Alright, now we're going somewhere. Now, when he makes the first serve, what is the other option that will happen in this situation?
You score your game.
Score or
Yeah.
not score. So, wins a point, lose a point, right? What about when he missed the first serve? Is it the same situation? Can he still win a point or not win a point when he missed the first serve?
No. You would serve again.
So, can we branch this out as a point and no point as well?
No.
No? Alright. Service. I am Roger.
Okay, fine.
I served. Boop! I missed it. Does that mean I don't have a chance of getting a point again?
No, you can serve again.
Because I'll do the second serve. So basically this is what it is. This is the second service.
I thought you wanted us to write another serve. Never mind. Okay. Point or no point?
Right?
Yeah.
So, is it safe to say that we can say that missing first serve means we made it on the second serve? Right?
Yeah.
That's another way of translating it.
Okay.
Missing the first serve means that we made it on the second serve.
Or didn't. Point or no point?
Can we still win a point? Yes,
Yes.
right? Point?
Do you
No
watch
point.
tennis?
Yes.
I can tell.
Alright, so now that we have our tree diagram, because this is important, you need to know your tree diagram, which is basically in mathematics, is either this or that. There's still, I have only 14 minutes? Oh! This or that. So, this or that, this or that, this, got it? Alright. It's like on, off, on, off, on, off. There's always just two options to keep it simple. Now, let's apply the information we have in this particular statement. Tennis player Federer made 63% of his first serve in 2011. 63% on the first serve. Right? Let's use decimal because we're going to be using a mathematical operation, and in mathematical operation we always use decimal, right? 0.63. Right? Making it on the first serve. So if he made it on the first serve for 63% of the time, what is the probability that he will miss the first serve? Complement, right? 1 minus 0.63, which is? 0.37?
Yes.
Okay. So that's how you formulate your word. Now, second statement. When Federer made his first serve, he won 78% of the points. Made on the first serve, made on the first serve, he won a point at 78%, right? So what's the probability that he will lose a point in that particular serve? 0.22. So you understand the relationship of complement of a given bit? What about the third one? When Federer missed his first serve and had to serve again, which is this, he won only 50% of the time.
57.
57. And what is the probability that he's not going to win?
43.
43. Alright, now let's answer the probability. What is the probability that Roger missed his first serve given that he wins a point?
So it said it in the question?
We're going to find all the probabilities first.
Oh, okay.
Yes, because it's conditional, right? So what are we going to do? We need to find the probability that he makes on the first term and he won a point. What's the probability of that happening? What do you think are we going to do to be able to figure that out?
Multiply.
Yes, multiply. So can you please multiply 0.63 and 0.78?
0.49.
Point
491
4.91.
4.
4.
How about probability that he makes the first serve but no point? Means he didn't win a point.
0.1386.
0.1386. Which makes sense. The probability of him winning a point is higher in this situation, right? What about the second event?
0.2109.
0.2109. And the last one?
0.1591.
1591.
Okay. Now, is this a legitimate probability? Can you please add them up if it's equal to 100? Use the calculator. It's approximately equal to 1.00?
Yes.
Oh, really?
Exactly.
Dang.
Yeah, exactly one.
See, this is a legitimate probability model, which means we're safe to use this to answer this question. So, given that he wins a point, what's the probability that he wins a point?
That he wins a point. And 0. Yeah.
So that will be your
Get,
denominator.
do you add them?
You add them. Because that's the probability that he wins a point, right? And what is the event? Probability Roger missed his first term, and then wins a point, right? So what will be your numerator here? Isn't it just 0.2109?
Yeah.
So it's 0.2109 over the sum of the probability of him winning a point. Got it? Okay. So let's see if that's the right answer or last right train of thought that we need to have for this problem. So here's our tree diagram, which is also in your book. So if you want to review on this, go to probability and you will have this particular problem. And we're answering each one of them so that we'll be able to find all the values that we need for our sample space. And we're looking for missed first serve and wins a point, right? Missed, yet wins a point. So we're going to be collecting A and B all over P of A. So probability of missing the first serve and win, missing first serve and wins is 0.2109, right? Over winning a point. Win a point, so you add them up. Is that right? Oh, we're so good.
Question.
Wow.
Negative. Is that formula right? Shouldn't
Yeah,
that be on the
this is the
bottom?
mathematical formula for this conditional probability, which for most students, it's Chinese.
Right,
But if you can understand it, which makes sense, right?
wouldn't it be P of A all over P of A? And then that would be
No, because the probability of A is winning.
okay.
And this one is winning and
Okay.
not making it on the first serve. Got it? That's why it's the intersection. The formula makes sense, right? Okay. The only challenge is you need to be able to translate it in your own language. And there are going to be many different events that you can answer given this particular experiment. It could also be, what is the probability that Federer will be missing his first serve? Oh, what's the probability that Federer will miss his first serve?
0.27.
Okay, so you're just basically basing it out of the table. Got it?
Yes.
Okay. Now, practice. Video share. That will be your homework because we've been here for more than an hour already. And it's the end of the day and we're almost dead. But make sure to answer this because on the next... Thank you so much for watching. This is Dr. Esperanza, and if you happen to like this video, i-like nyo na at i-share ang mga math videos ko para mas marami akong mga bata matulungan na kagaya nyo. See you again next time. Bye! So, dito na po ako sa Pasay City North High School. Kasama ko yung mga students. And pupunta na kami sa presentation at pinakain nila kami na sobra.